Okay, so we're now going to look at some proof questions. I've got three. I'll see if I can fit it all into this video. If not, I'll just do it over two videos. But yeah, that's what I'm going to go on to now, sort of exam-related proof questions that could come up. I guess they're sort of relatively easy since there's only finitely many ways they can ask you to prove something, because it's going to come from either proving it via the axioms, the corollaries and propositions, or some definition like conditional probability, for example, in this instance, that you have to use along the way. So after you've done a couple, you kind of get the idea or the rhythm of how to prove these things. So hopefully it should be okay. In terms of chapter 8, 9 and 10 for probability, I'm not going to do revision videos on those chapters because quite simply they're relatively easy. They're just simply revising formulas, revising the expectation and variance of particular functions. There isn't really any, I think, unorthodox in those chapters, so I'm not going to do videos on those. From now, if I can just find more examples of like Bayes' theorem and stuff like that, applying those questions, and I'll try do some all proof questions like I'm doing now. Okay, so we've been asked to show that for any three events A, B and C, with the probability of C being greater than 0, that the probability of A union B given C is equal to the probability of A given C plus B given C minus probability of A intersection B given C. Obviously, do pause the video and just and attempt the question if you can, and see how far you get. It's not a particularly difficult question. It's just a couple of things you have to remember. And yeah, that's fine to just pause the video and just look at the end of the video to see what the answer was. But yeah, so I'm going to go from the left hand side to prove this, right? So we've got the probability of A union B given C. So A union left hand. So all right, on the left hand side, what do we have? Right, so we've got the probability of A union B given C. So I'm just going to apply the definition of conditional probability for that. So that's obviously going to be equal to the probability of A union B intersection C over the probability of C, which was by conditional probability. I'm sure most of you have done that. Okay, so I'm not going to touch the denominator, the probability of C, because I see on the right hand side each of them have given C, so I'm going to want probability of C as my denominator, so I'm not going to touch that or make it a complement or anything like that. I'm going to leave that alone. So I just need to worry about the numerator. Well, what do I know about A union B intersection C? Well, we learned from structures that for any three events A union B intersection C, I'll just try and write in square brackets here. If you have A union B intersection C, this is the same as A intersection C union B intersection C. Obviously there's another one as well, but obviously this is the one that applies to our question here. So we can replace probability of A union B intersection C as A intersection C union B intersection C. So let's do that. So we have the probability of A intersection C union B intersection C all over the probability of C. So now I've got two events here. I've got the event A intersection C and the event B intersection C. So what can I do? Well, I can apply inclusion exclusion for two events, which is 3.6 right here. So I can apply this. If you don't see it immediately, which I assume you do, but in case you don't, obviously just let D equal A intersection C and let E equal B intersection C, and then just do it from there, and you'll see it immediately. So I can apply this to the numerator, and what do we have? Well, that means that the probability of A intersection C union B intersection C, that's going to be by inclusion exclusion, the probability of A intersection C plus the probability of B intersection C, and then minus the probability of A intersection B intersection C. And we know that this is all over the probability of C, But since my right hand side has them split up, I'm going to write a probability of C under them individually. So I can write like so. Probability of C. Right. And now we can immediately see that obviously by definition of conditional probability, A intersection C over C, well, that's going to be the same as probability of A given C. Similarly, for B intersection C over C, well, that's going to be the probability of B given C. And for A intersection B intersection C over C, well, that's going to be the same as the probability of A intersection B given C. And this is equal to the right hand side. So we've proven it quite easily. So hopefully that makes sense. Hopefully everything was clear. I think the main bit to remember was just sort of that the three events can be written like this. I think from there it's pretty easy to see that you do apply inclusion, exclusion, and then from there just go by the definition of conditional probability to get the answer. So in the next video, I'll have another question. I'll have another question on a proof-related question. Again, I guess it's relatively easy. I'm not really sure where these rank in terms of difficulty of hard or easy. These aren't from past papers nor exercise sheets. I've got this out of a book, and I don't really know how difficult they are. But hopefully it was clear anyway. Again, like I said earlier in the video, there really is only so many ways a proof question can be given to you, and there's only going to be so many ways to solve it because you only know so many things about it. You only know a couple of corollaries, a couple of propositions, a definition of conditional probability, a couple of theorems here and there. That's really it. So really, in essence, it should be okay to prove this. Hopefully it wasn't too difficult. But yeah, in the next video I'll have another proof type question. So yeah, obviously if there's any mistakes or anything like that, please do let me know. Or if there's any other videos that you'd particularly want, let me know as well. I'll try and get another video on Bayes' theorem, another example like that, because I think that's the hardest chapter of the entire module. So yeah, thank you for watching.